Find the values of h for which the vectors are linearly dependent. Okay, so we can call v1, v2, v3, and we write a linear combination c1 v1, c2 v2, c3 v3 equals 0. Okay, and to show or to make v1, v2, v3 linearly dependent, we need to make at least c1, c2 or c3 non-zero. Okay, 0, 0, 0 is always a solution of this homogeneous equation. But to make v1, v2, v3 linearly dependent, we need to find at least one of these three constants non-zero. So our goal is to make one of them non-zero. For that we need to find this h. Okay, so let's write the corresponding augmented system for this vector equation, and that will be just first vector 1, negative 1, 3, negative 5, 7, 8, 1, 1, h, and we are setting this to 0 vector, so 0, 0, 0. Now here is pivot 1, that's good, and we're gonna keep pivot here, we're gonna keep pivot here. So make this 0, make this 0, make this 0, and they might change. 7 and 8 could be changed. Okay, so 1, that's good, it's given 1, that means we wanna work on R2 to make this 0. Sometimes one thing, okay, sometimes these two rows, first, second, or second, third, or first, third, could be multiples of constant multiples. 3 times the third row could be 3 times the first row. In that case we can make all zeros. Okay, anyways, let's make this 0. R2 plus R1, we just add these two, and we can do same thing for R3 as well. Is a 3, so R3 plus, we are using this pivot, so negative 3 times R1. Okay, so not doing anything on R1, negative 1, negative 5, 1, 0, R2 plus R1, so negative 1 plus 1, 0, 7 plus negative 5, 2, 1 plus 1, 2, this is 0. Multiply this by negative 3 and add with R3, so 3 minus 3, 0, 8 plus 15, 23, h plus negative 3, okay, 8 plus negative 3, so h minus 3, 0. Okay, now this is good, so this is pivot, this is pivot. To make this pivot we have to make this 0, so 23. So to make this 0, let's make this 1 so that it's easier, because 2 we can multiply R2 by 1/2, so 1/2 times 2 will be just 1, and it helps to make this 0. Okay, so next thing is R2, so R2 times 1/2, so 1, negative 5, 1, 0, 0, divide by 2, 1, 1, 0, 0, 23, h minus 3, 0. So we want to make this 0 now using this pivot 1. So using this pivot we want to make this 0, so do not use negative 5, it doesn't work. But if it, never use this, because you always use pivot element to make other term 0. So working on R3, sorry, not H3, R3, third row. How? This is 23, means R3 plus, you multiply by negative 23 here, add with R2, that gives us 1, negative 5, 1, 0, 0, 1, 1, 0, this is 0, 23 minus 23, 0, h minus 3 minus 23, h minus 26, and 0. Okay, so we are trying to find non-trivial solution. Okay, suppose h is not equal to 26. If this is not equal to 26, then this is non-zero. This is non-zero means we got pivot in each row, first row, second row, third row, and there is no pivot in the last column. That means we have a solution. Okay, we have a solution, and if this is not zero, then we have pivot in each column, each row, means we get trivial solution because the last column is all zero. I mean, this is for C1, this is for C2, this is for C3. If this is not zero, then C3 times not zero equals 0, means divide by that not zero, so we get C3 0, C2 0, C1 0. So we get trivial solution when h is not equal to 26. Okay, so to find non-trivial solutions, in fact, we have to have a free variable. Okay, there is no pivot in the last column, so we have a solution, at least one solution. And to find non-trivial solution, we have to make this 0, one free variable. When we have free variable, we'll get infinitely many solutions. I mean, the unique solution, so whenever we have this system, one solution is always 0, because 0 times anything plus 0 times 0 times, that's solution. So we'll get consistent system, but we want to find infinitely many solutions. Okay, not the trivial solution, other solutions. For that, we have to make this free. Must, that's the only chance we have, because h can be taken anything, must make this column due to this free variable, must get free variable. And that happens when we have no pivot. So if we make all 0, then we get free variable, and h minus 6, 26 must be 0. Okay, to get free variable, that means h is 26. So in this question, if we take h equals 26, we'll have a free variable. That means infinitely many solutions. That means we have a these vectors are linearly dependent.